Then we can use this relationship to find the perpendicular slopes of particular lines. So if I have a slope of 1 to 2, so 1 up, 2 over, okay, my perpendicular slope is going to be negative 2 to 1. So if I'm going to go, instead of going up, I'm going to go down, and I'm going to go down like this, negative 2 and 1. Okay, so those two lines, and maybe I'll make sure that's more clear. So that line is 90 degrees to that line. Okay, and I can put them next to each other. I can see, yeah, that makes my 90 degrees there. Okay, so my perpendicular slope then is my negative reciprocal. So we can do the same thing here. We have a slope of negative 3, so 1 over 3 down, 1 negative 3. Okay, my perpendicular slope is going to be negative 1 over negative 3, or it's going to be negative, it's going to be positive 1/3. My reciprocal and the opposite sign. So when I draw this in, it's going to go run of 3, rise of 1. There's my slope. Okay, and if I compare those two line segments, there's my line segment here and here. And if I compare those line segments, yeah, they make my 90-degree angle here. Okay, so we can compare those so you can see the 90-degree line segments when we kind of put them a little bit closer together. Okay, so if we're going to find the slope between the points, perpendicular slope from between points 2, 5 and 5, 7, we need to first of all find the slope between the 2 points. So we're going to find the slope. It's going to be equal to the rise, which is a change in height, change in y, divided by the change in run, or change in width. So just make sure I did it in the right order. So 7 was first, so 5x being 5 is first here. It's in the right order, so I get 2 over 3. There's my slope. If I'm going to convert this to perpendicular slope, we're talking about negative 3 over 2. So that's my perpendicular slope. So we can check to see if this line segment here and this line segment here are parallel, perpendicular, neither, by just comparing the slopes. So the slope here is going to be the change in y over the change in x. So here I get 9 over 10. Okay, the slope here is going to be the change in y over the change in x. So negative 10 over 9. Yeah, taking a look at these slopes, they are reciprocals and opposite signs of each other. They are perpendicular. Okay, so we do the same thing here. We can compare these line segments by calculating the slopes. The change in y, 16 minus 8, the difference is the change, over the change in x. Again, just make sure I have it in the right order. If I don't have it in the right order, then I've calculated my slope incorrectly. So I'm going to have 8 over negative 6. Okay, here my slope is going to be the change in y, so negative 3 minus 9, over the change in x, 12 minus 3. This works out to be negative 12 over 9. Okay, these are both negative, so they can't be perpendicular if they're heading in the same direction. Okay, it's impossible for them to be perpendicular. However, when we actually simplify this ratio, this simplifies to 4 over 3, and we'll put the negative up top because it doesn't matter if the negative's on bottom, top, or side. if we simplify this, divide by 3, we get negative 4 over 3. So since the slopes match, although the ratios were not the same, when we simplify the ratios, they are the same. So these must be parallel. Okay, so parallel lines share the same slope. Lastly, we can compare these. So we're going to again calculate the slopes, the change in y over the change in x. I end up with 8 over 14 minus negative 2 is plus 2, so it's 16, so it simplifies to 1/2. Using the slope here, so 10 minus 1 over 7 minus 1. Okay, make sure the ones are on the same side here. I end up with 9 over 6. Okay, and that simplifies to 3 over 2. So these are not parallel nor perpendicular. So these are not parallel nor perpendicular. Okay, they share the same slope. There's no negative reciprocal relationship between the two slopes.